So in this instance, we're working with more complicated ratios rather than one-to-one ratios like we were in the previous video. So in a blast furnace, hematite, which is Fe2O3, is converted to iron. So we have 1 mole, 1 mass of iron can be obtained from 16 grams of iron oxide. So here's our iron oxide, so 1 mole makes 2 moles. So it is a 1 to 2 ratio. So if we take a look at this then, the number of moles is the mass over the MR. So the mass is 116 over 160. So that's 0.01, I think. 0.1 moles. So 1 mole makes 2 moles. So what we need to do then, because this is a 1 to 2 ratio, is times this by 2. So we will take our 0.1 and times that by 2 then. So we would have 0.2 moles of the iron being made. So that would be the mass of iron would be the 0.2 times the AR of iron, which is 56. So that should be, that will be 11.2 grams. Looking at the next one, what mass of calcium oxide forms from 200 grams of calcium if it's burnt in an excess of oxygen? So we can ignore the oxygen. If we take the calcium that we know we have, so the number of moles, and again it's a 1 to 2 ratio rather than 1 to 1. So we have the mass over the MR. So we have 200 grams over the MR, which is 40, or the AR, which is 40. So 200 divided by 40 gives us 5 moles. Now it's a 1 to 2 ratio, so 5 moles would react with, that's times 2 would react with, would produce 10 moles. So the mass will be the number of moles times the MR. So that's 10 times the MR, which is 56, which is going to give us 560 grams. And that's that one. Okay, looking at the next one then, slightly more interesting ratio this time. So we have 2.6 grams of aluminium chloride, and it was dissolved in water and silver nitrate. It was added to give a precipitate of silver chloride. Here's our silver chloride. Here's our aluminium chloride. So you can see this is a 1 to 3 ratio. So let's look at what we know so far. So we're looking at our aluminium chloride. So the number of moles is the mass over the MR. So the number of moles is the 2.67 of the aluminium chloride divided by the AR of the aluminium, so the MR of the aluminium chloride, which is 133.5. Which gives us 0.02 moles. So it's a 1 to 3 ratio, so we take our 0.02 and times it by 3, which should give us 0.06 moles. So the mass will be the number of moles times the MR, so that will be 0.06 times the 143.5 for our aluminium, for our silver chloride, sorry. So 0.06 times 143.5 gives us 8.61 grams. There's our answer. So in this one, what mass of silver chloride will be formed when 5.2 grams of barium chloride reacts with silver nitrate, both in solution. So here's our barium chloride making our silver chloride. You can ignore the silver nitrate and the barium nitrate. So it's a 1 to 2 ratio again. So if we take a look, then we have number of moles is the mass over the MR. The number of moles is the 5.2 grams. And the barium chloride is 172.5. Which gives us 0.03. So it's a 1 to 2 ratio. So So if we keep that number in our calculator, times it by 2. If we times that by 2, we'll have a 0.03 to 0.06 ratio effectively taking place here. So the mass of our product here, which will be the silver nitrate, is the number of moles times the MR. So 0.06 times the MR of the silver chloride, which is 143.5. Gives us 8.65 grams. Last one. The oxide of potassium, KO2, reacts with carbon dioxide to form oxygen and potassium carbonate. This reaction sometimes is used as a means for generating oxygen in submarines. They're called submarine candles. What mass of oxygen would be produced from 1,420 grams of potassium oxide? So here's our oxygen, and here's our potassium oxide. We can ignore the other components of this reaction. So this is an interesting one because it's a 4 to 3. It gets a bit more kind of interesting. This one. So number of moles is the mass over the MR. So we had 1,420 grams of potassium oxide with a MR of 71. Which gives us 20 moles. Now, because this is a 4 to 3 ratio, if we divide this by 4, sorry. And times by 3, that gives us 15. So it's a 4 to 3 ratio. So if we divide our 20 moles by 4 and then multiply by 3, that gives us 15. That's going to help us to work out the ratio. Well, that has worked out the ratio for us here in terms of how many moles of oxygen we're going to actually get in this reaction. So the mass will be the number of moles times the MR. So the mass is our 15 moles of oxygen times the MR of oxygen, which is the 32. Which gives us 480 grams. And we can do something a bit interesting with that number, and we will do so in a slightly later question. We'll be looking at molar volumes. So blend this now and we'll take a look at yields.